Welcome. Thanks so much for joining. My name is Nader Nanjiani, and I'm your moderator. We're so glad that you could join us for the first of our four-part webinar series called Raise the Bar on Data Protection with Cloud Storage. Thank you for joining me from our public sector team on today's webinar, which covers the topic of file storage. The topic for today is being led by our speakers, David DeLuca, a storage solutions architect, and Michael Goulet, storage specialist. And it goes as move to manage file storage, Amazon EFS and Amazon FSx. How to reduce costs and administrative overhead with AWS managed file services. Before we begin, please note, if you have questions, you can use the Q&A panel to ask those of our speakers. The slides from the presentation will be made available to you later as a PDF. And for any questions that don't get covered during the talk here, we will have the speakers follow up with you via email. And with that, let me turn it over to Michael Goulet to start the presentation.
Thanks so much, Nader, and everybody. Thank you so much for hopping on and meeting with us today. As part of the agenda, we'll go through an introduction to managed file services, what that is, what that means. We'll talk about Elastic File System. That's a fully managed file system for Linux-based workloads. From there, we'll go into a EFS demo. From there, we'll talk about FSx for Windows file services and what that means as a fully managed file system for those SMB workloads and Windows file servers. We'll have an FSx demo. And lastly, we'll go through our storage partners and how they can help with your migration and security when moving over from on-premise into cloud storage. And we'll follow up with a Q&A. So prior to AWS, I spent 10 years in on-prem storage, and customers always talk to us about managing on-prem storage arrays, and they come with a unique set of challenges. Storage arrays will hold lots of storage for a large number of applications and need to be properly sized to meet your storage needs for the next 3 to 5 years. As data continues to grow, so does a growing infrastructure costs, including storage hardware, storage networking, data center costs, and aging disks that data is housed on. On-premise storage can also be limiting to the amount of capacity. This not only affects the amount of data you can store, but also affects the amount of compute that can access the data. If the storage can't keep up with your applications, or end users won't be able to either. Lastly, keeping the storage up and running to ensure your end users and customers have continuous access to the data requires a lot of operational overhead. So fully managed, what that means to you. So probably something that almost everyone in the audience can relate to is that managing file servers is a lot of work. So before the cloud, you had to plan for capacity. So what does that mean? So when you either refreshing your hardware or buying something new, you kind of had to guess of what that capacity is going to look like in 3 to 5 years and make sure you bought enough to manage that. You have to procure and purchase that hardware. So that itself is a long process. To procure, you probably have to go through a POC of 5 to 6 different technologies that you're looking at. You have to make sure the one that you're making a decision on reaches the needs of all of your users. And once you finally make that decision of which technology you want to go with, then you have to purchase it. And that itself is a huge challenge. Making sure that you're getting the right software updates, making sure you're getting all the hardware that you need, making sure you don't have to go back and buy more hardware later in a year or two because you didn't buy enough capacity. But at the same time, you also don't want to buy too much capacity because then it's wasted dollars. You have to set up storage servers and volumes. So obviously, once you get the hardware here, right? If you're migrating from one technology to another, think about that process. Think how long that takes. It's 6 months plus, right? Just to get that hardware in-house, migrate the data over, and then set it up and get going. And now let's say you bought a 3-year maintenance contract. Now you're 2.5, maybe even 2 years left on that maintenance contract just from purchase. You have to detect, address hardware failures, and invest a lot of capital costs. And then from there, you also have to manage the software, right? So it's installing, configuring servers, it's setting up file systems, supplying updates, and then backups, right? It's not just managing the production data, it's also managing the backups. Think how much capital investment goes into that. And from here, I'm gonna hand it over to Dave DeLuca.
Thanks, Mike. So what we're going to talk about now is Amazon's Elastic File System, also known as EFS, and how it can address some of these challenges. So first of all, what is EFS? It really represents an evolution on the network file system. It's fully managed, it's cloud native, highly reliable, and cost optimized. And over the next couple of slides, we're going to dig in a little deeper to each one of those tenets. First of all, like any cloud native service, it's elastic. So it can grow and shrink on demand, and you don't have to provision and manage the underlying infrastructure and capacity, which was what Mike was saying before. You don't have to go and pre-provision a ton of space that you're not using yet. In fact, you're only going to pay as you go, and you're only going to pay for what you use. It's also incredibly simple to go with all the defaults in EFS. You can create a file system literally in seconds. As far as scalability, it's going to grow up to petabytes. There are a couple of options that I'm going to show you in the demo around performance modes as well as throughput, which would scale automatically with the file system, but you can also guarantee a certain amount of throughput if needed. And then lastly, integration. It could be used from on-premises, it could use between AWS regions, and of course with services within the AWS cloud. So it's very common to share EFS across multiple EC2 instances, or maybe as a shared file system for container services like ECS or EKC. Next, let's talk about reliability. By default, the data is going to be stored across 3 AWS availability zones. So the data would remain available even if an availability zone were to become inaccessible. And strong consistency, meaning that once a write is accepted, an immediate read is going to reflect that write. There isn't ever going to be a time in which you're getting an old copy of the data. From security, there are a lot of options to control things like network traffic. We can do things like network access control lists and security groups, as well as controlling access to the file and directories themselves. And of course, data is encrypted in transit and at rest. And lastly, it's global. EFS is available in every AWS region, and it has feature parity across every region. Next, let's talk about cost optimized. So on the left side of the slide, you see EFS standard, which is for frequently accessed data. And as I said before, it's going to be stored across 3 availability zones. So we're really guaranteeing a very high level of availability, even in the unlikely scenario that an availability zone is not accessible. We also have EFS standard infrequent access. So for files that still require that level of protection, but aren't accessed as often, we can tier them down and it'll be less expensive to store them. And again, this is something I'm going to show you in the demo. On the right side, we now have something called EFS 1 zone. So instead of storing it across 3 AZs, we're going to store it in a single AZ. This is really for data that doesn't require as high a level as availability. So in the unlikely event that that availability zone became unavailable, you wouldn't have access to the data, which is why, again, we want to make sure this is for data that's easily recreatable or data that is not mission critical 24/7. But it is much more affordable if that's the type of data that you have. And of course, there's a 1 zone and frequent access as well for those files that aren't accessed often. The real takeaway of this slide is that EFS has a lot of options to make sure your data is protected, but also cost optimized depending on the use case. A quick look at a customer case study. The BBC has an application called Red Button. This provides interactive television services. But the challenge was it was running on many disconnected platforms, a lot of different software and hardware vendors, and it was difficult to maintain. It was difficult to do any updates. They also were still reliant on a Linux POSIX compliant file system. So when they moved it to AWS, the key was having EFS that could still provide that shared file system so they didn't have to go and rewrite the application completely. What I really like is some of the benefits that get listed here, especially the ability to reproduce the environment in minutes, and ultimately it means they met their migration deadline and lowered costs. So a great success story about not only the benefits of moving to the AWS cloud, but how EFS really fit the niche that this particular application needed. Next, let's move on to a demo of EFS. Here we are in the AWS console. EFS is located under the Storage category. On the main EFS page, let's click Create a File System. You have the option of naming the file system. You then assign the file system to a VPC. If you're planning to access this file system from on-premises, be sure to select a VPC that is routable from your VPN or Direct Connect link. Amazon EFS offers you the choice of creating file systems using regional or one-zone storage classes. Regional storage classes store data within and across multiple availability zones. One-zone storage classes store data redundantly within a single availability zone at a lower cost for workloads that don't require multi-availability zone resilience. At this point, you can simply click Create to accept the default settings. For the sake of this demo, let's click Customize to take a closer look at some of the options. By default, automatic backups are enabled and will create a daily snapshot of the file system. You can also leverage lifecycle management by specifying the number of days that must elapse for an inactive file to move to the infrequent access tier. For performance considerations, most customers will select general purpose. However, certain workloads such as big data analytics, media processing, and genomics analysis may benefit from the max I/O setting. Please note that this setting cannot be modified once the file system has been created. Along those same lines, the bursting throughput mode will meet many customer requirements. This mode automatically scales to add more throughput as the file system grows. However, if you need to guarantee a certain amount of throughput, you can select Provisioned and specify the amount of throughput in megabytes per second. Your data is encrypted by default. And like any AWS service, you can always add tags to help identify and track your resources. Notice one setting that appears to be missing. You do not specify the size of the file system. It will automatically be created at a minimal size and will expand as needed. Because we selected regional as the availability, EFS automatically created a mount point for all availability zones within that region. This screen gives you the ability to specify the subnet, IP address, and security group for each availability zone. Had we selected one zone, we would have only seen a single availability zone on this screen. Finally, you have the option of overriding the default file permissions. The file system is now available. Note that since it is empty, the capacity is only 6 kilobytes. The next step is to attach this file system to a Linux instance. When you click on Attach, you'll see a couple of commands to mount the file system. Let's copy this bottom one into our clipboard. This is an Amazon EC2 virtual machine running Linux, which we'll use to demonstrate mounting the file system. The first thing we have to do is create a mount point. Let's create a directory called EFS to use as the mount point. Now we can paste the attach command that we copied into our clipboard. The file system is now successfully mounted. As expected, the file system is currently empty. Let's download some data from an S3 bucket just to have some sample files that we can work with. The download is complete, and we now have several files and folders in our EFS file system. A refresh of the console shows that the file system has automatically expanded to 2.99 gigabytes. EFS is, of course, a shared file system. Let's bring up a second Linux instance in which I have already mounted our EFS file system. So now we have two hosts connected as two different users looking at the same shared file system. Lastly, let's demonstrate that file permissions are maintaining the POSIX standard. In this left window, we're logged in as the root user. If we create a file, We can see that the file has been created with the default permissions, in which the owner has full control and everyone else is read-only. From the other host, we cannot edit the new file since we are not logged in as the file owner. We can change the permission to allow full control to everyone. Now that that change has been made, the other user can also edit the file. The takeaway is that EFS maintains POSIX file permissions. This concludes our demonstration. Okay, Mike, we'll send it back to you to talk about FSx for Windows File Server.
Great, thanks so much, Dave. So what is Amazon FSx for Windows File Server? It's a fully managed native Windows file system that's deeply integrated with AWS and all its services. Really simple. And there's two different opportunities in how you can really leverage FSx for Windows. First is the NAS lift and shift. So let's say, for example, you're not ready to move that application and re-architect it or refactor it and move it into AWS. But instead, you want to lift the application and just move it into an EC2 instance and leverage FSx for Windows natively how you're doing it on premise. It's great for home directories, line of business applications, really anything where you're not doing too much high performance, high throughput workloads. This is a great solution for that. And secondly, if you'd have moved your application up to AWS and you have refactored it and reworked it, obviously FSx works very well with all the different AWS services, from workflows to analytics, HPC environments, test dev environments, SaaS applications. So really, those are the two different ways to leverage FSx for Windows. Dave, I'm going to hand it back over to you.
Thanks, Mike. So this slide gives a look at some of the features on FSx for Windows. We know customers depend on a lot of features and capabilities from a file server. So the real core goal of FSx was to provide a complete set of enterprise-grade functionality. And since FSx is built natively on Windows, it fully integrates with all of the features that you'd expect, such as Active Directory, NTFS file systems, Windows access control lists, shadow copy, and deduplication. And because it's a managed AWS service, there's an additional set of functionality, such as the option to store in multiple availability zones, select whether the underlying disks are SSDs or HDDs, automated backups, and other features. While we're talking about backups, I just want to stop here for 1 second that there are two options. The first is Windows shadow copies. So these are just inline snapshots that the file system takes, and users can restore them on their own. So all they have to do is right-click on a file, go to the tab that says previous versions, and restore from there. But we can also do this within AWS at the file system level. So a snapshot will get taken either on a schedule or on demand, which are actually being stored in S3, and that's going to allow you to restore an entire file system to a particular point in time. And that's usually critical for meeting data retention or compliance needs. As far as references, there's a couple of different quotes here from 3 different customers, but what I noticed is there's a real common thread between them. They all talk about the advantage of working with a fully managed service such as FSx for Windows and not having to deal with all the things we talked about at the beginning of the presentation, dealing with managing the file system itself or the hardware or doing security patches, and ultimately customers just want to spend more time focusing on what's important to their business and less time managing the underlying hardware and software. Let's move on to a demo of FSx. In the AWS Management Console, FSx is located under the Storage category. Let's click Create File System. There are 2 versions of FSx. For this demonstration, we're going to focus on FSx for Windows File Server. We have the option of naming the file system. We now select the deployment type. Multi-AZ file systems are designed to maintain availability of your data in the event that an availability zone is inaccessible. Multi-AZs include an active and standby file server in separate AZs that are automatically synchronized. Single AZ deployment replicates the data within an availability zone to protect from component failure. However, in the unlikely event that an AZ is inaccessible, you would not have access to the file system. Next, we select the storage type. Amazon FSx provides consistent sub-millisecond latencies with SSD storage and single-digit millisecond latencies with HDD storage. For all file systems, FSx provides a fast in-cache memory on the file server. Next, we'll enter a starting capacity for the file system. FSx provides a recommended throughput based on the storage type and capacity of the file system. If you want to configure a specific throughput, you can select between 8 megabytes per second and 2 gigabytes per second. Under Network and Security, we select the VPC from which we want this file system to be accessible. If you're planning to access this file system from on-premises, please make sure that your VPC is accessible from your VPN or Direct Connect link. We specify the security group or groups, and we can select the preferred subnets within our VPC. Since we chose multi-AZ, we can select 2 subnets. Next, we need to configure Windows authentication using Active Directory. There are 2 options. The first is to use an AWS managed Active Directory. I've already configured this directory as test.corp.com. The second option is to connect to an existing Active Directory. Please note that your AD controllers and DNS servers must be reachable from the VPC subnets that we selected above. If they are, you can connect to your AD by specifying the credentials in these fields. Your data is automatically encrypted using AWS Key Management Service. We also have a couple of optional fields. FSx will create a default DNS name. If you want to specify custom DNS names, you can enter them here. Under Backup and Maintenance, you can enable or disable automatic backups, set a backup window, and specify the retention policy. Maintenance, such as software patches, occur infrequently. But when it is needed, this maintenance window is your chance to control what day and time that patching will occur. Finally, you can always add tags to help identify and track any AWS service. The file system has been created and is available. Note that we can manually modify the file system storage capacity and throughput at any time. The next step is to attach this file system to our hosts. I'm going to copy the DNS name into my clipboard. This is an Amazon EC2 virtual machine running Windows. This Windows host is a member of the same domain as my FSx file system. I'm going to type 2 backslashes and then paste the DNS name from my clipboard. This is our FSx file system. Notice that there is a default shared folder simply called Share. To map the share as a drive letter, simply right-click and select Map Network Drive. It's important to note that FSx is not a single share. It is a file system in which you can create multiple shares. I'm going to launch the Windows File Management Wizard. We then connect to the FSx file system. And we can use the wizard to create additional shares. If I refresh this window, our new department share is now visible. And like any Windows file system, I can create directories. I can assign Windows access control list permissions. And I can create files. This concludes our demonstration of FSx for Windows File Server. Mike, I'm going to pass it back to you to talk about our storage partners.
Thanks, Dave. So next, what we talk about is our storage partners. There's really two we like to highlight today. First, we want to talk about smart migration to AWS via Burst Fusion. And what they are is Fusion offers customers the ability to securely migrate data from the edge to the cloud or the cloud to the edge over high latency networks using patented ultra-fast technology. In this scenario above, the data is generated in a variety of public sector agencies and can be stored in various edge methods such as Outpost or Snowball, and needs to be transferred to a Fusion edge, which will then generate the data and transmit over ultra-fast to a Fusion controller, which will then move the data to the appropriate destination in an AWS storage or consumption in various AWS services as shown in the slide above. The next technology we'd like to talk about is Comprise. Comprise is intelligent data management that provides analytics-driven migrations that can help confidentially migrate petabytes of NAS data to Amazon EFS or FSx for Windows file server in the most cost-effective, fast, reliable, scalable, and automated way while minimizing downtime. Moreover, Comprise is a complete data management solution that continues to help you save our customers costs even when after the migrations are successfully migrated. Now, I'll give you an example. Is if a customer has petabytes or hundreds of terabytes of on-prem NAS data, and a lot of the times that data is just sitting there not being used. What Comprise can do is go and scan those file systems and then non-disruptively move the files that aren't being used into AWS for low-cost storage. From there, they can also analyze before you can migrate. So what does that mean? So Comprise enables you to understand your file data, usage patterns, age across all your data storage to identify and move the right data sets to AWS, just like we talked about. Know what data you're migrating and when. That is extremely important. Analyze across any NAS storage to understand data usage and plan migrations. And lastly, file and object migration and replication. Mitigate risk, reduce costs, and move to the cloud by migrating and replicating file and object data into Amazon EFS or FSx for Windows or Amazon S3. Migrate petabytes of data from the cloud or on-premise quickly, simply, and reliably with Comprise patent pending elastic data migration.
Time for Q&A. Mike and Dave, may I go ahead and ask you a few questions?
Absolutely.
Please.
All right, great. Well, thanks for doing a great job with that, Dave and Mike. So the first question is, and this is regarding EFS, how does one zone durability compare to standard?
So both one zone and standard are designed to provide 11 nines of durability over a given year. Ultimately, the difference is that EFS standard is going to spread it out across 3 availability zones. So we can sustain the loss of an availability zone. Whereas one zone, if we did lose that availability zone, you wouldn't have access to your data. So it's really a question of accessing it in case of an availability zone loss. But there are so many copies of the data that even within a single availability zone, it still meets the 11.9 standard.
Great. Well, I have a few more questions, but I just want to let the audience know. Keep a recurring question. A recurring question is whether the slides will be made available. And yes, the slides will be made available as a PDF afterwards. And if you have questions, please go ahead and post them. And if we can't, they don't get covered in the few I'm about to ask, then we will have the speakers write to you directly and answer you by email. So Dave, I have another one. What EFS settings can be modified after the file system is created?
So there's really 3. You can enable or disable automatic backups. You can modify or disable the lifecycle policy, and you can change the throughput mode. That was where we said either bursting, where it grows automatically with the file system, or provisioned, in which you pick a particular amount of throughput that you want to guarantee.
Got it. Thanks, Dave. Another one for you. How is FSx capacity charged? Is it the total capacity of the file system or just the amount of written data?
So it's just the amount of written data. So if, for example, if you provisioned a 2 terabyte file system, but it only written 1 terabyte, you'd only get charged for that 1 terabyte.
Good to know that. Okay, great. Any other thoughts before I go on to the next one, Dave, on that one?
No, I think that was everything there.
Awesome. What happens to my file system while maintenance is occurring?
So this is specific to FSx, that if you're running a multi-AZ file system, then during maintenance, we would actually switch over to the standby server, which is running in a different availability zone, and you wouldn't see that at all. And then once maintenance is done, we'd fail you back to the primary. If it was a single AZ file system, it would be temporarily unavailable during maintenance. Now, maintenance is usually only a couple of minutes. We ask you to specify a 30-minute window, but it's usually just a few minutes. So again, the big question here between do I pick multi-AZ or single AZ is, can I tolerate, a certain amount of time during off-peak hours, once in a while for the maintenance? If so, then if not, go with multi-AZ and you will always be available, even if maintenance is occurring.
Great. Thanks for clarifying that, Dave. For our audience, would you go on to the next slide? I might be able to comment through that if there's anything there. Otherwise, I'll just make the announcement. There it is. So I just wanted to let our audience know who looked at your demos and probably benefited from those demos that we have an evaluation survey that happens after this, right? Webinar ads. You'll see a questionnaire come up. You can schedule a one-on-one for your company or your organization with our AWS subject matter experts. And thereby you can have a group of your own colleagues together and go into a personalized tutorial around the FSx or the EFS topic. So if you're interested in something like that, do respond back in the survey, and we'll have one of our team members reach out to you and work that in. So that was the one thing I want to let those of us who might be interested in more information have that bit of knowledge. Also, as I mentioned earlier, this is a first of a series of a four-part webinar series, So we have one coming up on Backup tomorrow, same time. So join us for that one, and let your colleagues and peers know about it too. So with that, Dave and Michael, thanks for doing a great job today. Really appreciate it. And our audience, to our audience, of course, many thanks for being a part of this discussion. And we look forward to bringing you more such enlightening conversations. Hey, thanks so much and have a wonderful day. Bye all. Bye, Dave. Bye, Mike.
Bye, guys. Thank you. Thank you.